Hello and welcome everybody to Functions Lesson 1. So today we are going to just do a little intro into functions, what a function is and how to test whether a graph is a function or not. So we have been looking at relations in the last unit. So it says here, in a relation, each element of the domain is related to an element or elements in the range. We had x's and y's. But in this lesson, we are studying a special type of relation called a function. So a function is still a relation, but not all relations are a function. So I'm going to skip over the exploration, and I'm going to jump right to the next page here. So a function, or a functional relationship, is a special type of relation in which each element in the domain is related to exactly one element of the range. If any element of the domain is related to more than one element of the range, then the relation is not a function. So it basically needs to be a one-to-one. So every input, another way to say it is every input can only have one output. So we looked a little bit at arrow diagrams. So, for example, we would have something like 1, 2, and 3, and then they would have outputs, right? So your input was 1, your output was 4, your input was 2, your output is 7. If your input's 3 and your output is 10, this would be a function because each element of each input only has one output. So that would work. If we had an arrow diagram that was the same thing, 1, 2, 3, and we had 4, 7, 10, and we had 1 being an input going to 4, but also it went to 10, and then this 2 maybe went to 7, this 3 went to 4 and 7. This is not a function. Not a function. Because the input here of 1 now has 2 outputs. It has 4 and 10. So it is not a function. So your arrows have to go basically straight across in order for it to be a function. Each input can only have one output. For ordered pairs, we know ordered pairs are when we write our coordinates x, y. For ordered pairs, each x coordinate can only have one corresponding y coordinate. So each x can only have one y. So a good example is if we had a couple of, say we had 2, 3, and we had 7, 9. 7, 9. That's a function. Each input has one output, right? This input has one output. What's not a function is something like 2, 3, and 2, 9. You can see there that the input of 2 has 2 outputs, right? So same input, but 2 different outputs. So this is not a function. The same holds true for graphs, but there is a really nice way to check graphs, and it's called the vertical line test. Vertical line test. So what I want to do is we're going to look at a few graphs here, but I'm going to come back to this. So first I want to skip over and go to the vertical line test. It is exactly what it sounds like. It is the vertical line test can be used on the graph of a relation to determine whether the relation is a function or not. So you should be able to draw a vertical line anywhere on your graph, and it should only cross the relation once. If it crosses more than once, it's not a function. So let's go back up to our graphs, or flip back to your graphs here, and let's test it. I'm going to use green. So graph A, I'm going to draw a vertical line here and here, just at random. It has to be able to work everywhere. You can see we have the function, or the line. It only crosses once. both of those lines. So this passes the test, right? Passes the test. Passes. So this is a function. So for graph A, for each input value, there's only one output value. True. Let's look at one that doesn't pass. So for graph D, if I were to do the vertical line test here or here, you can see that the function or the line crosses my vertical line twice. Same with right here. So this is not a function, not a function. I'm not going to worry about this table. I think the biggest thing is the ability to be able to say, okay, if we look at graph B, it passes the vertical line test. It doesn't matter where I draw a vertical line on here. The line only crosses once. That's great. But in graph C, if I draw a vertical line, that graph crosses that vertical line twice. So graph B is a function, and graph C is not a function. So it's just a special type of relation where each input only has one output. And if you think about that in graph C, if we have an input or an x value of negative, or even an x value of 0, we're going to have a y value of 2.1 and 7.9 or something like that. So there's two outputs, two y values for one x value, and we can't have that in a function. So if you come down here, we can also look at whether or not these are functions using ordered pairs or arrow diagrams. So if you look at the first one, A, we have 5, 8, 6, 7, negative 5, 3, 2, 3, 6, and 8. So you can see here that it looks pretty good, but we have the input of 6 having two different outputs. So 6 as an input can either produce 7 or 8. So not a function. One input can't have two outputs. This next one, we have 3, 3, 2, 3, 4, 5, and negative 3, 2. So each input has only one output. It's okay if they're the same output. So you can see here our output is the same, right? So if I put input a 3, my output is 3. If I input a 2, my output is also a 3. But that's totally okay. So if I drew my arrow diagram, it might be easier to see. My inputs are 3, 2, 4, and negative 3. And my outputs are the second values, 3, 3 goes again, 5, and 2. And so if I have 3, the output is 3. If I have a 2, the output is 3. If I have a 4, the output is 5, and negative 3 is 2. So these two right here have the same output, but each of them only has one output, right? So that is a function. Oh, hang on. Function. In C, you can see A has an output of P, B has an output of Q, and C also has an output of Q. So this is not a function. Not a function. Because both B and C... Oh, wait. I got myself confused. That is a function. Because they each have only one output. It can be the same output. That's okay. But they can only have one. If, for example, it looks like this is where I confuse myself. A, B, C, P, and Q. If one of these inputs went to both outputs, then it wouldn't be a function, if that makes sense. For D, we have a graph, so we want to check the vertical line test. Every time you have a graph, the vertical line test is the best way to do it. So you can see... I'm going to move everything. No. I don't. hang on. That's probably not right. That's okay. Let's look at D. You want to use your vertical line test. So why aren't you registering my pen? Here we go. Right there, we only have one output or one dot. Right, oh, I missed it, but right there we only have one. Right there we only have one, but here we have two. That means this x value, right down here, if that was x is 1, it's going to have two corresponding y values. So that's not a function, despite how bad my lines are. And again, if you're using a graph, you are going to use your vertical line tests. So for f, anywhere I draw a vertical line, that function is only going to cross it once. So yes, this is a function. For G, if we draw vertical lines, it looks good so far, but here, that function crosses 3 times. Or that line crosses 3 times, so it's not a function. I think that's it. That is it right there. So just for this lesson, the biggest thing is what is a function and how do you test to see if it is a function. So it's a special relation, and where each input has one output. Then you're done. Awesome. Thanks for watching. Don't forget to like and subscribe.